Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session, we will discuss the voltage booster section and power factor correction section of this LG Inverter AC board. We apply line and neutral here at these 2 points. Then there is soft starter circuit and inrush protection circuit. Another power supply provided to low voltage power supply SMPS circuit. This supply turns on. Here we provide standby signal. This standby signal will turn on these regulators. These regulators will provide 15 volt and 5 volt. 5 volt for microcontroller, 15 volt for this PFC controller, current sense IC, IPM modules. When the indoor unit or remote unit will provide signal to turn on the compressor, at that time this microcontroller will issue command to turn on this current sense IC, to turn on this PFC controller. When this PFC controller will receive command, turn on command, power on command, at that time it will monitor the voltage at DC rail through these resistors and present position of AC voltage. What are the line voltage? What is the output voltage? And it will take difference between these two voltages. If there is large difference, for example, we need 350 volts, and here are equivalent DC voltage, we can say 300 volt, so there is 50 volt difference. Based on this command, to maintain the voltage, to boost the voltage, it will start its drive signal. It will drive this IGBT low side driver. Then we have two IGBTs here, 1 and 2. And we have two rectifiers, these two inductors. It will boost the voltage. It will provide PFC drive signal. This drive signal will come to this low side driver. It will drive these two IGBTs. It will pump the voltage into this inductor reactor. It will add the voltage in the DC rail voltage which are coming from this bridge rectifier. So it will add the voltage. It will adjust its duty cycle, pulse width modulation, to obtain the required voltage level. And at the same time it will monitor the current that will be drawn through these IGBTs while creating a pulse. Let's see the circuits. Here it is using R2A 20114 AFP IC. AFP and ASP. It is continuous conduction mode interleaving PFC control IC. It comes in two package styles, 40 pin and 20 pin. This 40 pin IC. This 40 pin IC, pin number 1, last pin 10, 11, 20, 21, 30, 31, 40. And if there is 20 pin IC, that will dual and line package. Here is pin definition. The first two pins, pin 1 and pin 2, these are frequency modulation. Here it is not using these two pins. Then pin number 3, that is V reference. V reference. When it will receive VCC voltage, it will provide V reference at pin number 3. So at this pin, it is using this canister, V reference C01A. So it is output pin. Then there is pin number 4. Pin number 4, that is PFC IC on off. This on off control, PFC on off control, it is coming from microcontroller pin number 35, this pin. Pin number 35 of microcontroller is connected to pin number 4, that is here. So this IC will receive power on command. Then at pin number 28, here is pin number 28, this one, it will receive voltage from this VCC capacitor. It will receive 15 volts from this VCC capacitor, and these 15 volt are coming from this capacitor that is here. When this power supply will turn on, it will provide 21 volt. When we will apply standby signal here at this optocoupler will provide drive signal to this IC KIA278R15P1. It will provide regulated 5 volt. These 5 volt will reach here pin number 28 of this IC. 28 number pin, when it will receive 15 volts, it will provide 5 volt output at pin number 3. Then pin number 5, that AC input voltage. This is pin number 5. And if we see, here are input voltage through this D01, D02, these two diodes, and then we have 1, 2, 3 resistors. And if we check voltage that are coming from this current sense IC, AC voltage are rectified through these two rectifiers, series rectifiers, and then we have 1 mega ohm, 3 resistors in series, and then these voltage are reaching to this point, and it is connected to pin number 5. Pin number 5 will receive the present condition of the AC voltage VAC. When it will receive present position of the input voltage, and at the same time there is V out, there is another feedback, that is pin number 17. It will receive feedback voltage here. So two type of input voltage. What is the present position and what is the output position? These two signals are reaching here. Then pin number 7 is analog ground. Pin number 8, that is delay control, error delay. Here R40A not connected. If there is a resistor connected, it will adjust the delay period when the error fault will occur, how much time we want to provide as a delay time. Pin number 11, that is error output. If there is any fault, if there is overcurrent, OCP1, OCP2 in any IGBT, if there is overcurrent or any gate drive is failed, error block will generate error and it will provide to pin number 11. This pin number 11, that is coming out from this point. This error will reach here at this point R13. It will reach at R13B, and this R13B second end is connected to PFC IC fault, this signal that is coming from here, and it is reaching to this IC, pin number 21, 22, 23. If there is any problem, for example IGBT is short circuited, it will draw more current. Let's see the current sense circuit and then we will understand the function of this IC. First we will see pin outs. Pin number 12, that is not connected. Pin number 13, that is current sense setting. This resistor, it is to adjust the current limit. Pin number 14 is connected to this soft start capacitor, this one C06A soft start. Then pin number 15 is compensation, 16 not connected, 17 that is feedback. Pin number 17 is receiving feedback from this resistor network R23A, R17A, these two lines. These both lines are reaching here. One line is reaching here at this point, then this, then here this base, then from this P3 transistor Q03A, From here it is reaching at this point, this, and then it is reaching second end is connected here, and it is connected to this resistor is connected here, and then this center node is connected here. Then over voltage protection, pin number 18 is connected to over voltage protection, that is connected to this resistor network, and it is taking feedback from this resistor network. These three resistors for over voltage protection, these three resistors for sensing feedback, how much voltage are there on DC relay. And then we have 22, that is I ramp. Pin number 23 and 24, that are current sense amplifier compensation network. 24 and 23. 25 and 26, that is current sense input. Here it is using two resistors, two IGBTs, two resistors. Let's see it here. This R02F, its feedback network is reaching here, and then it is coming here at this point. From here it is reaching to board second side, then this signal is reaching at this point. These 2 points are current sense 1 and current sense 2. Two signals are reaching here at these 2 points. Then supply terminal, pin number 28. Then there is drive signal. 32 and 34, these two signals are reaching here at these 2 pins. This pin and this pin. 2 and 4, these two signals. These both signals are passing to these 2 points. This one here, then this resistor, this one here, then this resistor. Then second side, it is reaching to this point, and this signal, it is reaching to this pin. So we have 100 ohm resistor between this driver stage, then this drive signal will reach here. In the output side of this fan 3227 IC, it is driving this 20 ohm resistor, and this drive signal is reaching to this IGBT gate, and this drive signal to this IGBT gate, this gate pin of this IGBT. When it will provide drive signal to this drive 1, it will create switching pulse here. Normally the positive voltage are passing through this reactor to this D1 diode, that is one diode here, second diode here. IGBT will provide pulse here to this inductor L1, and second IGBT to second inductor. We have two inductors, two diodes, two IGBTs. This IGBT will drive this inductor. Normally the current is passing to the capacitors. Capacitors are connected here at output terminal. When pulse will arrive here, it will turn on. At that time, it will provide a short link for very short duration, positive to this ground side, because this is negative side of the bridge rectifier. So this pulse will cause to create magnetic field in this inductor, in this core. When the pulse will turn off, this collapsing magnetic field will provide reverse voltage to the applied voltage. That voltage will come in series, so two sources will added. For example, this collapsing magnetic field will provide 30 volt pulse, and here we have 320 volt. 320 plus 30 volt, 350 volt will receive here. Same time, this will turn off, this will turn on from here, gate drive 2, gate drive 1. When it will turn on, at that time it will create pulse in the second inductor. Same way, magnetic field will expand, then collapse, so the voltage will add in the applied voltage that are coming from bridge rectifier. So it will boost the voltage, and it will monitor the voltage here. If any time the voltage value is increased, at that time it will turn on this discharging circuit, that is bleeder circuit. There is a relay, and these 4.7k resistors, 1 2 3 4 5 6 7, these 7 resistors are in series, and these will provide voltage drop from this negative line. Negative line is connected at this side and positive line is connected to this relay terminal. When this relay will turn on, it will provide switch between these two terminals. When it will turn on, so at that time it will discharge these capacitors. If the voltage are increased, it will cause to drop the voltage from here. If the voltage are less than the required voltage, it will boost the voltage from here. When it will provide switching pulse, at that time in these resistors, that are these two resistors here, R01, R02D, R01D and R03D, R04D, these resistors will drop voltage, and this voltage CS1, this signal, this pulse will reach here, and this CS2 pulse will reach here at this point, and these amplifiers will amplify the pulse, and if there is overcurrent, OCP1 signal will created and OCP2 signal will created. These both signals will reach here at error block. At the same time, GD2, gate drive 2 and GD1, gate drive 1, these 4 pulses will reach here at error block. This error block will immediately provide error signal to the microcontroller that there is something wrong. Pin number 37 and pin number 38 are CT and RT. This is CT and this is RT. Timing resistor and timing capacitor. Pin number 39 and 40 are not connected. So this is the circuit configuration. We cannot turn on this circuit because I don't have indoor unit board. We need sensors, temperature sensors and other things. We need a software based command which will be communicated through these optocouplers to this microcontroller. Microcontroller will issue command from pin number 35 to pin number 4 at the brown out input. At that time it will turn on. In case of any malfunction, it will report back to this IC that there is PFC circuit fault. PFC circuit fault is communicated from pin number 11 that we discussed, that we checked here, and it is coming to this R13 resistor. We can check the voltage at pin number 5, that is input AC voltage, and we can check the feedback voltage at pin number 17, but this time I cannot power on because I don't have the input circuit, but this is the function of this circuit. Okay, now let's trace the circuit. This is negative terminal. Negative terminal is reaching to IGBT's negative side. Positive rectified voltage are reaching here at this reactor pin, and it is going to reactor's one side pins. And the second side of these reactors, we have 2 pins. One side of reactors is connected to positive terminal directly, but the second side, 2 wires are connected separately here. One is here, second is here. If you see here, reactor this point is connected to this IGBT and this rectifier, and this end is connected to this IGBT and this diode. Output of this diode is connected to positive terminal, and this one is also at the same point. So same as in this simple circuit, reactor One end is connected to common point, that is here. Then we have these two coils, these two inductors. These are connected here, and output of this reactor is connected to diode, that is here. IGBT, diode, inductor one end. Diode, reactor one end, and IGBT. These are connected together. Same in the emitter. This current sensor resistor, and second this current sensor resistor. So if this PFC section is not starting up, we can check 5 volt signal. When we apply turn on command, power on command through indoor unit, at that time pin number 4 brown output must receive input signal. At that time it will power on its output circuit. But if it is not turning on, then we can monitor pin number 5. Then we can monitor pin number 3, reference voltage 5 volt, and we can check gate drive 1, pin number 34, that is this one, and gate drive 2, this one. And we can also monitor these pins for current sense circuit. This is PWM drive. We can also check from here these 2 points, or these 2 points the same. Same way, here is fan 3227 IC. Here is its enable signal, enable 2 and enable 1. Drive signal is reaching at these 2 pins. This is ground and this is supply pin. It is also receiving voltage from this capacitor. So in this way we can monitor this circuit. So if it is not maintaining the voltage, we can test these signals, we can test IGBTs. Second thing, when I was checking this board in microscope, if you see here these IGBTs, when there is double side print and high current section, that time soldering must flow to the inside. While soldering, we can see this pin. This pin have a minor amount of solder, but this is blank. When there is high current, at that time a minor amount of resistance will create bad soldering, dry joints. And if we monitor the second side, after passage of time, this joint will become overheat and it will become dry soldered, because there is little amount of solder. After passage of time, this soldering will cause to create dry joints and circuit will not work properly. Fan 3227, this IC, it is used here. Pin number 7 is driving one IGBT, pin number 5 is driving second IGBT. So it will receive command at pin number 2 and pin number 4. Pin number 1 is enable A and pin number 8 is enable B. At that time, this driver signal will buffer the signal and it will drive the IGBTs. I hope this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.